Oh hi, didn't see you there. How did you get? You might be wondering, who are you? Why are you on my feed? What's the point of this video? Did I turn the oven off? Fear not, as all these questions and more will be answered in the next 20 or so minutes. Not the oven one though, you better go check. It's okay, I'll wait. Okay, good? Good. So, let's start at the beginning. Who am I? Well, I'm Eric. The eagle-eyed among you might have noticed that the channel's name spells that out. Pretty clever, huh? Yeah, I thought so too. No wonder I didn't actually come up with the idea myself. Anyway, moving right along. As the name suggests, I'm an engineer that just so happened to be raised in Kingston. Now, not to split hairs, but I wasn't actually born here. I went to a university named Kingston University. Shocking concept, I know. With that said, I've spent about 10 years of my life in and around this area, so I think it still counts. Some background. I only got into engineering seriously when I started university, and in particular when I stumbled upon a video by this old Tony. I was so mesmerised by him making something on the lathe that I thought to myself, hey, I'd quite like to do that. So I spent the next 5 years building a small machine shop in my spare bedroom, as one does. In fact, this December marks the 5th year anniversary of this workshop. It all started quite humbly with just a 3D printer and a mini lathe, and over time it just grew to, well, this. I often get asked, what do you actually make in your workshop? It's a surprisingly difficult question to answer. What does one make in a machine shop? Well, loads of things, but I'm aware that this is quite a boring statement, so instead of talking in monologue for 20 minutes, why don't I show you instead? Machine vices such as this are fantastic at holding square parts in place, which counteracts the forces of the cutter, normally an end mill, thus allowing you, the operator, to make cuts of varying sizes. However, since owning this vice, I've always found myself needing a reference point. Once you take the workpiece out of the vice, the odds of putting it back exactly where it was originally are statistically quite slim. Possible, mind you, but unlikely. There are ways around this, in particular by using something like a DTI stand to butt up against the workpiece, but I've always found this a bit boring. It certainly works, but what's the point of spending money on tools if you're not going to use those tools to improve the tools that you already have in the first place? This is a milling machine. It's a Walco WM16, and I've had it for a number of years now. It's no Bridgeport, nor should it be treated as such, but it has produced very respectable parts over the years, and I've grown quite attached to it. Not literally, of course, that would be very uncomfortable. Now, generally speaking, a milling machine makes parts square, whilst a lathe makes parts round. That is an oversimplification of what the machine is built for, but for the sake of this video and everyone's time, let's just leave it at that for now. Now, if this doesn't make much sense to you, don't worry. Hopefully by the end of the video it'll become clear as to what the problem really is and how I intend to tackle it. Until then, let's continue. Here's a badly drawn 3D sketch of the finished product. In case it wasn't obvious, CAD isn't my strong suit. Right, first let's make the part that I deem the most exciting. For all intents and purposes, it's simply a knob, and I could have easily made it out of brass and added a nail to it, but I feel it's been done many times before, so I'll add my own twist to it. Additionally, this is titanium. Granted, it's not the easiest material to work with. In fact, it can be rather unpleasant. Titanium is much like stainless steel in that it tends to work hard in the moment you look at it wrong, and to top it all off, it's also a very tough material, so carbide tooling is a must. A second reason as to why I'm using titanium will become apparent a little bit later on. But for now, enjoy some tightly edited lathe footage. Evidently, achieving tight tolerances on parts is far more important than making sure my camera is in focus. There, that's better. I suspect this might be somewhat of a running theme during this video. Sorry. For anyone interested, I'm using a Polish CCGT carbide insert. They're not great for taking big cuts, but considering my lathe is smaller than some tailstocks on bigger lathes, it's not exactly an issue. I'm using my UR32 collet chuck on this build quite a lot. I do have a 3-jaw chuck as well, but the added benefit of concentricity goes a long way for parts such as these. Also, I don't have to worry about the jaws marring up the surface either. I must say, seeing the reflection of that surface finish never gets old. I've decided to make a threaded bushing, which I will glue in place with Loctite 603, since tapping threads into titanium, well, let's just say there are more fun ways you can spend a Thursday evening. Despite how trivial dimensions on parts like these are, it's always extremely satisfying to hit a dimension spot on. There's one way of summoning gods of chatter, it's by using a dull drill. Hear that? Yeah, let's fix that. There, much better. Besides the surface finish, cleanliness is the most important step to Loctite adhering properly. Many people argue that Loctite is just superglue, but there are far more intelligent people than me developing this stuff, so I'm not one to argue. It has also proven itself many times in the past, so I'm not one to turn my nose up at that either. And yes, I am fully aware of the irony that is using a vice stop to build a vice stop. As mentioned before, titanium is a very hard material, therefore carbide tooling is a must. Here I'm using a solid carbide 8mm 4-flute end mill. I imagine using a ball nose end mill would probably produce better results, but my mill doesn't have anywhere near enough rigidity to do that, since the cuts get progressively bigger as the cut gets deeper. Considering I actually wanted to finish this part at some point this year, I omitted the idea of Chinese water torturing the part, and instead I'll plunge mill each cut. Granted, this isn't the most efficient way of doing this, nor is the surface finish anything to write home about, but given my small machines, I find this works best. A hex collet holder works brilliantly for jobs like this. Alternatively, I could have used a dividing head or a rotary table, but who's got time for that? I did the same thing to the other knob, then anodized both of them in this dark shade of purple. If anyone's interested, I might make a video about anodizing titanium in the home workshop, since it's surprisingly easy and the results kind of speak for themselves. Sorry about the 3D printer singing its song in the background. This is what happens when multiple projects overlap. Right, time to make the main body. Here I'm using an indexable face mill. The diameter of the cutter is rather big for the part, hence the noise, but I've opted to use it since it produces a fantastic finish, which will be important later on. There are those dreaded focus gremlins again. I'll use an edge finder to find the centre of the part, centre drill, and then ream the hole. There's nothing quite as satisfying as a precision fit part. Alright, enough of that. In many ways, this part worries me the most. The channel I need to mill is quite long and relatively deep. I opted to chain drill most of the material out first, followed by a 2-flute end mill to take it down to the final diameter. Given the length of the cutter, the surface finish really suffered as a consequence, but this is just one of the challenges of using small machine tools. And of course, let's add a chamfer to the slot for good measure. Now I'll drill and tap the hole for the retaining screw. This will hold the stopping pin in place. Now, time for one of my favourite surface treatment methods, cold blue, also known as gun blue. I believe the chemical name is selenium dioxide, and I personally use Philips Professional Cold Blue, and I've had good results with it. I choose to apply the cold blue with a brush because this allows me to see any imperfections and fix them by cleaning the area with IPA and applying the solution over that. I'll now clean the part off with water to stop the bluing reaction. Lastly, I'll add some 3-in-1 oil to protect the part. Time to make this part really look the part. That's right, it's time to add more chamfers. Brandon from Inheritance Machining is the absolute master of this, and naturally a big inspiration to this feature. If I trusted myself a little bit more, I would cut all the chamfers on each face in one operation rather than taking the part out of the vise each time, but I've already sunk enough hours into this part not to want to scrap it because of a miscalculation. I have to admit, that turned out really well. The contrast of the dark finish and the chamfers really stands out. I'm very pleased with that. Lastly, let's make the threaded shaft. It's a fairly simple part with only a handful of features, but I'm making out of tool steel for no other good reason than I can. Additionally, tool steel round stock comes ground to dimension, which is a nice bonus. Tapping tool steel, or silver steel if you're in the UK, can be quite hard on the tool, even though the part is in its nil state. With that said, this operation did result in a casualty. This was definitely the last thread that this die ever cut. I'll leave a small undercut for the thread so I can screw it right up to the shoulder. Finally, let's cut some spanner flats in order to tighten down the tool properly. It just so happens that the 8mm flat is the same spanner size as the square drive for my milling machine's drawbar. I made this last part off camera since the video is already long enough. All I did was put it in the lathe, file it, and then polish the round end. Again, this part is tool steel, although this time it was a design choice given the tight tolerance fit needed. Right, let's put it all together. Well, it works. Given that the body swivels, in addition to the length adjustment, makes it rather versatile. I'm very happy with how sturdy the tool is, since the whole point of it is repeatability. I'd go as far as to call this build a success. Well, dear viewer, hopefully you made it this far. If so, thank you. This has been a very long and arduous process spanning several months, not helped by the fact that I knew virtually nothing about shooting or editing video. I'd like to give a special thanks to Brandon from Inheritance Machining. His help and support throughout this project has been absolutely invaluable and it really means the world to me. If by some miracle you haven't seen his videos, I implore you to go watch them all. Anyway, thanks for watching. I'll see you next time.